So BSc Sem 1, okay, unit number 1, we start. Unit 4, okay, already we close. Now study of limit and okay, continuity. First of all, limit of function. Limit of a function. One variable and two variable. One variable in paper 1, maths 1. Two variable in paper 2. Okay. So I hope we study in the paper 1. Again, I revise. Okay, limit of the function. Okay, one variable. So let f be a function defined from I to R. Be a function defined on interval I. Suppose say this closed interval AB, except possibly at x0, any point of the interval AB. Okay, so this interval AB, so x0 is at any point on the interval AB except at this point. Okay, supposed to be. Then a real number L, small l, okay, is said to be limit of f of x function. L is said to be limit of the function f of x at that point, this point, x equal to x0, if condition, definition, okay, if for every epsilon greater than 0 there exists delta greater than 0 such that, okay, mod of x minus f0 is less than delta, then we have mod of f of x minus l limit must be less than epsilon. Okay, point x equal to x0, at that point means mod of x minus f0 is less than delta, then mod of function f of x minus limit l is less than epsilon. Okay, then okay, we can say this l is a limit of the function f of x tends to x0. So this notation. Okay, then that number l here, that is known as limit of this function at which point x equal to x0. So limit of the f of x as x tends to x0 equals to l will be a limit. Okay, so this is like definition, simple, big definition statement, but remember these two lines. Okay, so one variable f of x. Now two variables, similarly another definition of two variables. Okay, so let f be a function defined from E, suppose, to R, set of real number. So here this E is a subset of R2, two dimension. Okay, subset of R2 is defined in E. Set E now is a two dimension set. Two dimension is interval, one dimension. Now two dimension, x axis and y axis. Okay, and E is a one set. Okay, subset of R2. R2 means two dimension, xy plane or yz plane. Okay, this one. Now there is a point. So in the one dimension, okay, only f0 is a one point. Here f0, y0. Okay, 0 y0 two dimension point, pair point. Okay. And so this f0 y0 is any point of that set E. Okay. Then a real number okay, L same as one dimension, L is here, L is said to be limit of f of xy function. Now f of xy, two variables, f of xy, one variable f of x is said to be limit of the function f of x, f of xy if condition same epsilon delta for every epsilon greater than 0 there exists delta greater than 0 such that condition now, C condition now here. This is now one variable, two variable now, in place of ex now, xy pair, in place of ex, f0 y0 pair, less than delta, same. Then mod of f of x, in place of f of x, f of xy function, two variable, L is L, epsilon is epsilon. Okay. So one variable and two variable. One variable f of x, two variable f of xy. X minus f0, one variable because x equal to f0 any point. So here xy pair, in place of x, xy pair. In place of okay. Or from this we can say if this mod means what? Distance between them. Mod means distance formula. So this is same as root of x minus f0 whole square plus y minus y0 whole square, distance formula. This mod means distance between the 2 point, xy point and f0 y0 point. Okay. Also here xy point. Okay. Distance between them. Distance formula x minus x0 whole square, y minus y0 whole square less than delta. Okay. That means what? We can say x minus f0 is less than delta. Also their mod. Similarly, y minus y0 is less than delta. Okay, root of square of this will be less than delta. That means obviously every pair, this pair must be less than delta. This pair must be less than delta. Okay, and this. And here we say L is a limit. L is called as a limit of the function f of xy. Limitation now. In the one variable, x tends to f0. Here in place of x, xy tends to f0, y0. Okay, so this is difference. So L is called as a limit of the function. Okay, limit of the function f of xy, and this like limitation. One variable, x tends to f0, x tends to 2, 3. So this is difference in a one variable and two variables. Okay, so this definition, remember, one variable and two variable. One variable f of x function, two variable f of xy. So this some changes in the definition. Theorem. So first theorem of this, if limit of function f of xy, of course, as xy tends to f0 y0 at a point f0 y0 exists. If limit exists, then it is unique. Unique means only one. Okay, every function has only one limit, and there will be two limits at the one point. Okay, point change, other limit. So every function must have only one limit. We have to show. How to show? We assume two limits are there. We assume two limits, and lastly we show they are equal. Proof suppose. Okay. Suppose that this function f of xy at a point f0 y0 has two limits. limits L1 and L2. Okay, this function f of xy has a two limits x0 and y0, L1 and L2. Therefore, by definition, limit of this function f of xy at xy tends to f0 y0. One limit is L1 and second limit is L2. Okay, two limits. Therefore, by definition now apply definition here and also here. First of all here. So what is the definition of it? For every epsilon, so I take here epsilon by 2. Epsilon by 2 plus epsilon by 2 will be epsilon. Finally, I want epsilon. Okay, if you take epsilon, then what happens? Okay, epsilon plus epsilon, 2 epsilon. Okay, so avoid this. Okay, so for every epsilon greater than 0, there is this delta 1. Because two functions are there, two limits are there. So for this first delta 1 and for second delta 2. Okay, such that definition mod of xy pair minus f0 y0 pair is less than delta 1, then we have mod of f of xy minus L1 is less than epsilon by 2. Okay, one different. Also for second function, similarly. Okay, similarly. Okay, second function L2 limit for every epsilon by 2 greater than 0, there exists delta 2 greater than 0, such that same definition mod of xy minus f0 y0 is less than delta 2, then we have mod of f of xy minus L2 now limit is less than epsilon 2. Okay, this definition and now this definition. Now problem, okay, with the two deltas, here delta 1 and here delta 2. Okay, so take I want minimum only delta. So take let delta is a minimum of both delta 1 and delta 2. This for delta 1, this for delta 2. Okay, so for this delta equation 1 and 2 are true. Both equations are true. So for first equation delta 1 and second delta 2. Now, okay, comes to the proof. We have to show both the limits are equal, means L1 equals to L2. We assume there are two limits and lastly we have to show they are equal, means L1 equals to L2. That means what? L1 minus L2 equal to 0. Okay, or mod of this L1 minus L2 is equals to 0. Okay, mod. So consider this such a way which we have to show. So mod of L1 minus L2. Consider and lastly show. You know mod is always okay positive greater than 0. So we know this like you have to use to adjust function f of xy. So subtract and adding f of xy, adding and subtracting fx. So this I think I want f of xy minus L1 I want minus L common, f of xy minus L1, f of xy minus L2. Separate mod now less than mod of f of xy minus L1 plus mod of f of xy minus L2. So by equation number 1, this is less than epsilon by 2, this is less than epsilon by 2, means epsilon. Okay, so mod of L1 minus L2 is greater than 0 or equal to 0 and less than epsilon. But we know this epsilon is arbitrary. Epsilon is arbitrary. Arbitrary is our choice. So this must be equal to 0. Cannot be greater than 0. This must be equal to 0. Mod must be equal to 0. No chance of greater than 0. So mod 0 means what? Term 0. Mod is never 0. Mod of any quantity, okay, is okay, never 0. Therefore this term must be 0. So therefore L1 equals to L2. Okay, so we assume there are two limits. Lastly they are equal. So therefore limit is unique. So any function, every function has only one limit. Huh? Okay, now definition is okay, repeated limit. Repeated limit or iterated. Iterated limit means what? The limit x tends to x0 of limit y tends to y0 of f of xy. This like limit x outside and y inside, or also limit y outside, y tends to y0, and limit x tends to x0 inside f of xy. So that is called repeated limit. Okay, so it's simple. For example, this, let f of xy equals to x square into y square divided by x square into y square plus x minus y whole square. Okay. So say limit x tends to at a point 0. X tends to 0, limit y tends to 0 of y tends to 0. So 0, y tends to 0, so 0 by any term 0. Or second limit, okay, y tends to 0 and limit x tends to 0 of f of xy. Function, okay, same, x square y square plus x minus y whole square. X tends to 0, 0, this is 0, this is a y square, again 0 by any term 0. So both the limits are equal, generally equal, okay. Any apply, first apply y and then apply x, okay, both must be. Yeah, देखो this is how one.